Let f be the function defined as follows. F of x equals the absolute value of x minus 1 plus 2 for all values of x that are less than 1, and ax squared plus bx for all values where x is greater than or equal to 1 and where a and b are constants. And so we'll move to part A of this question, which is if a equals 2 and b equals 3, is f continuous of all x? And for this one, we're going to move over here, and all this is asking is if a is 2 and b is 3, would it be continuous? And for something to be continuous, they just have to, whatever point they would share, which in this case would be 1, the value there would have to be the same. And so for this one, I just did the same system, which it has there, and I went ahead and plugged in 2 for a and 3 for b. And then down here, since x is the only value that matters, I plugged in 1 for all of the x's, and so you have the absolute value of 1 minus 1 plus 2, which would give you 2. And then down here, for all the x's, we also plugged in 1, so it's 2 times 1 squared, which would be 2, plus 3 times 1, which would be 3, and add those together, and you get 5. And unfortunately, 2 does not equal 5. Therefore, it is not continuous. Alright, now we'll move to part B of this problem, which is describe all values of a and b for which f is a continuous function. Now this is a little bit more tricky, but the concept is basically the same. For two different equations to be continuous if plugged into a function, all they have to have is the point that they share has to be the same. And so we would set these equal to each other. However, we're not dealing with just 2 and 3 anymore, we're dealing with a and b. And so we put these equal to each other, and as we already found out, this equals 2. And this here, when you plug in 1, it just gives you a plus b. And so you get a plus b equals 2. And that's how you describe that problem. That's answer B. And then for C, which we'll move to now, is for which values of a and b is f both continuous and differentiable. And this one, slightly more tricky as well. What I did first is I took the derivative of the first function that it gives you, the derivative f of x, and then we went through, and the derivative of this, of the absolute value of x minus 1 plus 2 for the values where x is less than 1 is negative 1. And the derivative of, if you look at the derivative of ax squared plus bx, just gives you 2ax plus b, just simple derivative. And then from there, you have to have, for something to be differentiable, the derivative of both of them at the same point which they share, which yet again is x equals 1. The derivative at that point has to be the same. And so we would go through and do basically the same thing we did before, and we would have to say that 2ax plus b, and in this case x is 1 because that's the point they share, has to equal negative 1 because that is the derivative of the first part. And so we'll move over here, and you get 2a plus b equals negative 1. And then we also know that a plus b equals 2. And this is what makes it continuous, so differentiable, continuous. And then this is just a simple system of equations, and so you would just solve it. And what I would do is I would substitute, and I would say, solving this one for b, you'd get b equals 2 minus a. And then I would plug it into the first one. And so you'd get 2a plus 2 minus a, because you're plugging in the b. And that equals negative 1. And so you'd get 2a minus a equals negative 3. A equals negative 3. And then we would plug that back into this equation to find out what b is. And so we get negative 3, which is a, plus b equals 2. And so b equals 5. And that is our problem.